With me is Larry Williams. Larry is the Director of Product Management at ANSYS, and we're going to be talking to Larry about the company's technology strategies. Larry, thank you very much for joining us today, and tell us about where your company is going with its technology.
Well, we've been in this business for a long time. In fact, we pioneered the 3D high-frequency electromagnetic simulation with the HFSS product, and over the course of time, we've discovered more and more broad applications towards electronics, but also, of course, microwaves and RF. And so we keep pushing the technology forward. And you'll see here at the show, we've been highlighting some of the things that are coming in the future, HFSS 14. And we've recently announced several things that have come out in the software, including an integral equation solver, so that's a departure from our original finite elements. We're now talking about a physical optics solver. We released last year transient in using finite elements, and a really interesting technique called the finite element boundary integral method, where we link together integral equations with finite elements. So the overall strategy here, if I can explain to your viewers, is that it's not just about delivering a particular solver technology, a new solver technology like physical optics or integral equations. We're making all of them work together. They're all in the same interface, and we hybridize those codes. So this is a core strategy for the electronics business unit of ANSYS, is to build together these solvers to be able to assemble a model and then apply the proper numerical technique to a particular portion of the model. And then using a hybrid solution technique, we can solve those together. Another core strategy for our group is to leverage modern compute hardware, especially high-performance computing. We see more and more of our customers going towards cluster computing, but also just multiple cores and multiple processors. And we've leveraged that into an HPC offering, high-performance computing offering. And it leverages advanced techniques, of course, multiprocessing, shared memory multiprocessing, but also a distributed method called domain decomposition. So we have individual domains of a problem, and each domain, each portion of a single problem can be solved on a different computer, a separate computer. And as we drive forward, each of those domains could be a different solver technique. Okay. So we're really driving to this hybrid idea, high-performance computing. One last area that I think is very important is the automation. As I mentioned earlier, 20 years ago or 21 years ago when HFSS was released, it was really focused for microwave engineers. And of course, it is still the most valuable tool in the market for those engineers. But we see more and more of electronics being adopted. And those engineers would like greater automation. And that's true. I think we want automation for any discipline. And so recently we provided what we call a solver-on-demand technique. What it does is allows from a planar layout with schematic and layout inside of the ANSYS Designer product, the ability to spawn an HFSS simulation directly from that layout. So this great automation with links into Cadence, links into Mentor and other framework standard file format exchanges like ODB++. We can bring in a package and a board, or a package and a board together, and simulate those problems immediately with ports set up and boundary conditions all set up. So it's highly streamlined and much more accessible, I think, to a broader class of electrical engineers.
Excellent. Larry, thank you very much for that overview, and thank you for joining us today. For the engineering viewers, is there a website they could go to where they can get more technical detail about your company?
Of course, ANSYS.com. There's plenty of material there highlighting all of the details of especially the HFSS 13 release, ANSYS Designer product, our printed circuit board tools like SI Wave and such. So there's plenty of materials there.
Thank you very much, Larry.
Sure.